Hello, so today we will be talking about a decomposition reaction involving fermentation. Now, fermentation is a complex chemical process of making wine by converting glucose into ethanol and carbon dioxide. And as you can see, if we take 1 mole of glucose, and this is glucose, which is the C6H12O6, a solid, and we break it down through decomposition, it will yield, which is the arrow, yield, both 2 moles of liquid ethanol, which is C2H5OH, and it will also yield 2 moles of CO2, which is carbon dioxide gas. And I also like to go ahead and write down the mole ratios right here. So I have 1 mole of glucose, which is the 1 mole of glucose. And then I also have the 2 moles of ethanol with the 2 moles of ethanol. And this is my balanced equation. And then I also have my 2 moles of carbon dioxide. They're all equal because it's a balanced equation. So I also like to go ahead and write down and highlight my mole ratios. So as you can see, I have it highlighted for each of the mole ratios. And then I also have it highlighted in my equation. And then I also have it highlighted down in my problems to make it easier to see while I work on the problems. So let's get started. So the problem A is we calculate the mass of ethanol produced if 500 grams, which is 500.0 grams, of glucose reacts completely. So like entirely, there's none left. So first we start with the 500.0 grams of glucose over 1, just to leave that there. And then, so we want to convert it to, first we want to map out what we want to do. We want to convert this to moles of glucose, and then we want to convert it to moles of ethanol, and then we want to convert it to the mass or grams of ethanol. So first we figure out how we can cancel out the grams of glucose to get it to moles. Now, as we know prior to this, we know that that 1 mole of a compound is equal to the molar mass of all the elements combined. So like the 6 carbons, 12 hydrogens, and 6 oxygens. And you add up the molar mass, and I got 180 grams for glucose. And so the grams of glucose and the grams of glucose canceled out because one's on top, one's on bottom. And then to figure out that makes 1 mole of glucose. Well, now we want to cancel out the 1 mole of glucose, and we want to turn it to the moles of ethanol. As we saw up here, we know that 1 mole of glucose is equal to 2 moles of ethanol. And the mole of glucose has to be on bottom so that they both cancel out. And then the 2 moles, now we're into moles of ethanol. So then, now that we've got to moles of ethanol, we want to move to grams of ethanol, not moles, my bad. So we know that 1 mole is equal to the molar mass of the compound. So 1 mole is equal to 46 grams, which is 6 H's, 6 carbons, and then 5 hydrogens, and then 1 oxygen and another hydrogen, so 6 hydrogens. And then when you put all of that into the calculator, so you multiply everything at the top, and then you multiply everything on the bottom, and then you divide the top by the bottom. And I got 255.6 grams of ethanol. So therefore, 255.6 grams of ethanol will be produced when 500 grams of glucose reacts completely. Now that we're done with our little warm-up, question A, now we can move to question B. So we need to calculate the volume, so liters, because mass was grams, so volume must be liters. We need to calculate the volume of carbon dioxide gas, which is the CO2, produced at STP if 100.0 grams of glucose reacts. So it's very similar, except we have to convert the grams of glucose into the liters of carbon dioxide. So first we gotta map out what we want to do. So we want to go from 100 grams of glucose to moles of glucose, and then we want to go from moles of glucose to moles of carbon dioxide, and then from moles of carbon dioxide we want to get to liters of carbon dioxide. So now that we know what we want to do, we're going to take what they gave us, which is the 100.0 grams of glucose, which is four significant figures. And that's what they had up here, which is why my answer was in 4 significant figures. Forgot to mention that. But so it starts out with 4 significant figures, 100.0 grams of glucose. And then we know that 180 grams of glucose is equal to 1 mole, like what we did up here. And then the top and the bottom of the grams of glucose cancels out. So now we're down to 1 mole, which, yes, 1 mole of glucose. So then, now that we know from previously, we know that 1 mole of glucose is equal to 2 moles of carbon dioxide. See how the mole ratios is very useful, so I like to start out with that. So now that we have our mole ratios figured out, we need to know what we want to cancel out. So we wanted to cancel out the moles of glucose, so I put it on bottom. So now they cancel out. Now that we're in moles of carbon dioxide, we need to figure out how to get to liters. Well, we know that 22.4 liters is equal to 1 mole of a compound. So we have to put 1 mole of carbon dioxide on bottom, that way it cancels out on top. And we know that it's 22.4 liters of carbon dioxide. And then we're done. We just have to multiply the top by everything, and then multiply the bottom by everything, and then divide the top by the bottom, and you end up with 24.9 liters of carbon dioxide. And so 24.9 liters of carbon dioxide will be produced when 100.0 grams of glucose reacts. And now we're all done. Thank you for watching.